When we left off here comparing the z and the t distributions, we noticed that the t distributions are symmetric around the center. They have kind of a bell shape, and that the larger your sample size, which means the larger your degrees of freedom, the closer the distribution is to the normal distribution. So we want to kind of write that up along with all the properties of the t distribution we can figure out. So first things first, there are different t distributions for different degrees of freedom. So all the t distributions are different. So I guess I should say different t distributions for different degrees of freedom. Realize that this means that there are infinitely many t distributions, t curves. There has to be, because there's one for every possible degrees of freedom. Next, we see that the curves are all centered around or symmetric around the center, which is at the mean, which is equal to 0. Right? Then, with the area under the entire curve must be 1. Has to be, because it's a probability distribution, and probabilities always must sum to 1 over the entire sample space. Now, if the area under the entire curve is 1, and the center is at 0, that means that the area to the left of 0 must be the same as the area to the right of 0, which is equal to 0.5, or half. And now the x-axis is a horizontal asymptote in both directions. It's a horizontal asymptote to the left and to the right, as you can see from these t-curves drawn down here. But the t distribution is more spread out than the z distribution. It has a higher standard error, if you will. And then last but not least, as your sample size increases, that's the density curve of t gets closer to the z distribution. That's what we were seeing right here. As n increases, your degrees of freedom increases, the t distribution becomes more like the normal distribution, the z distribution. All right, so then I have two t curves drawn here. If I could get to them. My computer's being a little possessed there. There we go. All right, so two t curves are drawn below. One with degrees of freedom is 4, and one with degrees of freedom is 1. So you're supposed to label each one. Now, I've already labeled them, so take a look and see if it makes sense. Degrees of freedom larger means the curve's going to look more like a normal curve. That means it's going to have smaller tails and a taller peak. So the black curve is degrees of freedom is 4, and the gray curve is degrees of freedom is 1, because the gray curve is shorter at the peak and it has much wider tails, much fatter tails, if you will. All right, there we have it. So the gray curve is degrees of freedom 1. That means sample size, by the way, was 2. And the black curve is degrees of freedom 4, which means that the sample size was 5. All right, now we're going to determine our t values here. So we're going to find the t value such the area in the left tail is 0.005, where n equals 23. We're going to draw a labeled sketch, which I've already drawn right here, and you're going to find the value with your calculator. Okay, so you draw a t-curve. Now a t-curve, when you draw it by hand, looks pretty much like a normal curve. It isn't a normal curve, but it looks like one. It technically has fatter tails than a normal curve and a shorter peak. All right, now we know that the area in the left tail is 0.005, so we shade the left tail. We put t equals question mark over here. That's what you're looking for. Okay. All right, now I want to find that value. I'm going to show you how to find it two ways, with a calculator and with a t-table. They're both useful in their own right. So a couple things. Realize that if n is equal to 23, that means your degrees of freedom, which is n minus 1, is equal to 22. This will be the row of the t-table. That'll make sense in a minute. So degrees of freedom is 22. Then we need alpha. Alpha is our area in our tail. So the area in the tail is 0.005. In the left tail, I should say. The area in the left tail is 0.005. All right, so now I'm going to grab my calculator I'm going to clear this out. I'm going to show you how to use the inverse t function. Inverse t is number 4, right here, number 4. And just like with inverse norm, it always wants left tail area. So you say 0.005. There we go, 0.005. And my degrees of freedom was 22, if I'm not mistaken. Let me go back. Yep, 22. All right. Then I go down to paste and press enter. And press enter. Now, only the TI-84s have this option. TI-83s can't do this. This is one of the reasons that TI-84 is required for this course. So I'm going to take a picture of it, copy. I'm just going to paste in here for a second so I can see it. So the T value is negative 2.189, or 2.819, sorry. So, and I'll give T a little bit of notation in a bit, but for right now I'm just going to say it's approximately negative 2.819. Now it shouldn't be any shock to anybody that it's negative because it's on the left side of 0, right? So since it's on the left side of 0, of course it's negative. If it was on the right side, it would be positive. I don't need this anymore. And that's how to find it with the calculator. So we used, I better type this up. So T was equal to inverse T, and then we said 0.005, comma, 22 degrees of freedom. So that's the calculator entry. Just on a side note, the inverse T, so note, inverse T is left tail area, comma, degrees of freedom. All right, so if that's the case, what's another way to find it with the table? Now, what am I talking about with regards to the table? Well, you're given some tables on your exam that you're allowed to use. Let me go grab them. They're in your course pack. They're usually a bright neon orange color in the back of the course pack. So you can pull them out and staple them and put your name on them because you can use them on the test. All right, so here's the table sheet. And you can see the first one has a random number table, which we don't really need. And we don't really need the standard normal table. I never use it. It's not worth your time. But what you do need is the T distribution, this one right here. So you're talking about the area in the tail is 0.005. So you want to go to the 0.005 column. And you want to go down to the degrees of freedom is 22. And you can see the number right there. It's 2.819. Just like we said it was. Now the table is always the area in the right tail because they wanted to make all the numbers positive. But we have to know, oh, okay, this would be in the left side because it's to the left of the center, which is mean, which is 0. And since it's to the left of center, then it must be a negative value, not a positive value. So the column of your table that you would go to is 0.005. The row is 22, and then you get the same number, 2.819. Or you can just use inverse T. All right, now that we know how to do that, let's do it some more. Let's find some more T values. So I have all the instructions here on how to do that. Just a reminder that the area is always the left tail area. That's the big key there. And then the degrees of freedom is DEF. Another thing to note, and this isn't really important for the calculator, it's just important in general, which is that there's a symbol notation for this, which it's not a squared. I don't know why I have a little squared in there. Let me fix that. There we go, T alpha DF. So the T value is followed by your subscript, and then sometimes they'll put a little comma. Sometimes they won't, it just depends. But sometimes they'll put a comma and then actually write the degrees of freedom right there. So for example, this one would be 0.02, so that's the area in the right tail. Now the symbol always has the area in the right tail. The calculator needs the area in the left tail because that's the way calculators work. But the symbol will be area in the right tail, so alpha, and then degrees of freedom. All right, now you can use inverse T or you can use the table, either one. The problem with the table is that it's limited. There's only a certain number of values in there. The calculator can find any value, right? But the table can only find so many of them. There we go. All right, so I want t 0.02 comma 20. That means the area in the right tail is 0.02. That's my alpha right in here. So you can see that little area right there is 0.02. There it is. Now you can see it a little bit better. And I'm looking for this t score right here. So that's t 0.02 comma 20. Now the area in the tail is 0.02. In the tail is 0.02. That's in the right tail. Right tail. So the area in the left tail then is 0.98. So area in left tail is 0.98. And your degrees of freedom would be 20 because they say so. That's the comma part. So df equals 20. So this is your row on the table, t-table. And this is your column. Well, 0.02 is your column technically. Okay. Well, why do I figure out the 0.98 then? Well, because that's what I would need for the calculator. Okay. So the calculator will use 0.98. The table will use 0.02. So either one. And this will be your row. All right, so let's grab the table one. Let's see that. I gotta grab the table. It's right here. Okay, so I'm going to go to the 0.02 column, and I'm going to go to the row number 20. So 0.02 column, row number 20, and I see it's 2.197. And since it's on the right, I know that that's correct. So t 0.02 comma 20 would be 2.197 approximately. Now how do I get that with the calculator? If I want to use the calculator, I would do inverse t, but the calculator always needs the left tail area. So you'd say 0.98 comma 20. Let me prove it to you. Second distribution, it's above your variables button. Pick number 4, say 0.98, 20, enter, enter. And there it is, 2.197, right there. There, and I just boxed the 2.197. Okay, now let's do a confidence interval, since that's something we're going to need. So we're going to find the critical t-values for 98% confidence with n equals 67. So I made a t-distribution right here. I have the center, which is 0.98. And since it's a confidence interval, I'm going to have two tails, one on the left, one on the right, because the confidence interval makes up the center. Then I have alpha, which is the complement of that confidence level, which is 0.02, and alpha over 2, which is 0.01. That'll be the column of the t-table, right? Then your n is equal to 67, which means your degrees of freedom is equal to 66. Okay, that would be the row of your t-table. Now there's a problem with that, and I'm going to show it to you. It's that it doesn't exist. So let me grab the t-table. So I want 0.01, but I want 66, but there is no 66. This is why you're happy you have a TI-84. If you don't have a TI-84, use whichever one's closest, which in this case would be 70. So you'd use the 2.381. There we go. Use the closest one, which would be 70. So if I have the calculator, if I'm fortunate enough to have that, I'd use inverse t, number 4, 0.99, because 98 plus 01 makes 0.99, 66, enter. Or if you like, you can use 0.01. It'll just give you the negative value. You technically want the positive one, but it doesn't really matter. If you get the negative one, just make it positive. It doesn't make any difference. So you get 2.384. From the table, it's not as good. It's 2.381. Not terrible, but not as nice as having it from the calculator. Of course, on your exam, I will want the exact answer if you have a calculator, but if not, then you can